Hello, everyone, and welcome to this citizen science webinar for our project on river flow and ecology. I am just going to share our presentation. Okay, so the title of our project is Biological Tools to Measure the Impact of Flow on Ecology in Irish Rivers. This project is based at the Marine and Freshwater Research Centre at Atlantic Technological University, and we are collaborating with Munster Technological University and the Environment Agency in the UK, and the project is funded by the Environmental Protection Agency. My name is Martin Gamble. I'm the project manager, and I'm also a researcher on the project. So we're covering biology in this project. There are three major strands that we're focusing on, or three major work packages. One deals with macroinvertebrates, one deals with fish, and one deals with macrophytes, or the plants that live in rivers. I am mostly involved in the macroinvertebrate work package, and some of my colleagues are working on the fish and on the macrophytes work package. So I'm just going to concentrate on macroinvertebrates here to give you a flavor of what sort of work we're carrying out. So we obviously have different types of rivers. In this picture here, we have a slow-flowing, relatively deep river, which we can tell by the fact that there are water lilies growing on the surface. And in that type of river, you might expect a particular type of biological community. So the types of macroinvertebrates that you might expect to find, possibly lots of different species of beetle, that prefer slow-flowing waters. So this is an example of a whirligig beetle. In a different type of river, such as this faster-flowing mountainous river, you would expect a different type of community. So the types of invertebrates that you might expect to find here, for example, caddisflies that are adapted to fast-flowing waters, such as Odontocerum albicorni, to give it its scientific name. So depending on the type of river we're dealing with, we'd expect to find different types of biological communities. And if we have information on the biological community at a site, we should be able to tell something about the current and previous flow conditions or flow regimes at that particular site. So as I said, we've been working on this over the last number of years. We've been surveying rivers around Ireland. So these are our researchers carrying out macroinvertebrate surveys. So we sampled at a number of different sites around Ireland in 2021 and 2022 and took those samples back to the lab, and they're currently being processed at the moment. So the idea is we will identify the invertebrates found at different sites, and we should be able to link the invertebrate communities with prevailing flow conditions. These are the sites that we've covered, so 47 survey sites around the country. We chose the sites based on a couple of different criteria. So they had to be sites with either good or high water quality according to EPA assessments. So they shouldn't have been impacted by, say, organic pollution, for example. We chose sites that were close to a hydrometric station or a hydrometric gauge that was currently measuring flow, so within 1 kilometer of a hydrometric station. And the reason we did that was that so we'd be able to look at the relationship between the macroinvertebrate community at the site and the flow regime at that site. So we have information on the macroinvertebrates and on the flow at those particular sites. This is an example of a flow record at a site. So there is information on flow from hydrometric gauges that are managed by different bodies throughout the country. So the Environmental Protection Agency and the Office of Public Works manage a lot of these hydrometric gauges. This is an example of a good continuous flow record. So the example I've given here runs from 2014 to 2019, but we've got a good flow record over that period. There's periods of high flow, periods of lower flow. If we have information on the macroinvertebrate community at that site, we should be able to look at relationships between flow and the macroinvertebrate community at that site. So there are different ways that we can look at flow ecology relationships. As I've said already, we can or should be able to tell something about the flow regime at a site based on the biological community at that site. We also have information at some sites on, or very good information on flow regimes because there are hydrometric stations measuring at those sites. But we've got those stations at a limited number of sites. There's lots of rivers and lots of sites in the country that aren't covered by these hydrometric gauges. So possibly at those sites, if you gather information on the biological community at the site, you should be able to tell, based on the species that are living there, what the prevailing flow conditions at that site are. And as well, if you're monitoring the biological community over time, you should be able to detect changes in the flow regime. So there may be changes resulting from climate change, for example. There may be changes if there is abstraction pressure at a particular site. So that could be tracked using the biological community. And that's one of the aims of our project, looking at those flow biology relationships. So those are ways that we can look at hydrological conditions at a site. But in relation to what we want our citizen scientists to do, we want to approach it in a different way, using a smartphone app. So there are a number of apps that have been developed recently that allow you to take recordings or measurements from different river sites. The Crowdwater app is particularly useful for what we want to do. It's a nice app, it's easy to use. It allows you to measure or monitor changes in water levels at a site. And those changes in water level can be linked then to changes in flow at a site. So the Crowdwater app, there's lots of information on their website. You can register on their website under that Join Us menu. You can also register when you download the app, so you can register on the app itself. The menu in relation to the Crowdwater app will provide a lot of useful information. So this is just an example of some of that information. So you'll find information about what the different parts of the app will do or will allow you to do. What we're interested in for this citizen science project is the option to record under the virtual staff gauge. So the virtual staff gauge allows you to put a virtual gauge on your site. So this is an example here. So this is a virtual gauge. You can see the zero level at the level, current level of the river. So this is what you do when you first set up a site. You put the virtual staff gauge on that site at the current water level. Then when you revisit the site, you will be able to record how the water level has changed. So if the water level has increased maybe by 1 or 2 or 3 categories, you would select whichever one is most appropriate. If the water level has decreased, you'd choose -1, -2, -3, again, whichever one is most appropriate. So that lets us track changes in water level over time using this virtual staff gauge. The Crowdwater group are based at the University of Zurich. They, as well as having the website, which provides information about the app itself, they also have a YouTube channel, which has useful videos that gives useful information about how to use the app, and also information about some of the other things that they're doing with the data that they're gathering from the app. I've just included a couple of short videos from their YouTube channel here. And this first one gives you information about how to set up a site, how to set up a location to take measurements of water level over time. So I'm just going to play that. It's about 2 minutes long. Okay, so that was just a very quick look at how to set up a location. I suppose the main things are choosing the virtual gauge to put on your picture. So you choose the gauge that's most appropriate to the current water levels. So there's a level of judgment as to whether for that river they're currently low, medium, or high. There's also a level of judgment involved in how large or small you make that virtual gauge. So it should be large enough to cover expected rises and falls in water level, but not so large that any changes in water level aren't picked up on the actual gauge itself. So there's a little bit of judgment involved there. The next video, again, quite short, it's 1.5 minutes, looks at how to take a new measurement at a site that you've already set up. So I'll just play that. Apologies, I'll skip this out now. Okay, so that was how to take a new measurement at a site. So you go into the site that has already been recorded and using the virtual staff gauge, determine whether the water level has risen, has dropped, or stayed the same, and make that recording. So once you've got a site set up, it shouldn't actually take too long to take new recordings at that site. This is just an example of how you might do that. So on the left, the picture on the left, we've got the original setup picture for that particular site with the virtual staff gauge. Set 0 is set at the current water level. They've highlighted a rock in the picture using that red circle. That is a useful reference to try and track maybe rises in water level. So then looking at the picture on the right-hand side, again, that rock is highlighted with the red circle. So you can see from using that as a reference that the water is much higher than it was in the original picture. And using that rock as a reference, what they decided is that we're in the +3 category on that virtual gauge. So that's what is recorded. This is a paper produced by some of the Crowdwater people. I've just put it here to demonstrate the usefulness of the data gathered using the app. So this is crowd-based water level classes, the same sort of data we are asking our citizen scientists to record. And they've shown how it is useful, this type of data is useful for calibrating hydrological models. So, the data that you gather for this project, we would expect to contribute to good science, that we can gain good information about hydrological conditions at the river sites that are used or that are selected by you for these records, these measurements. This is just one graph I took, or a figure I took from that paper, just to show that these water level measurements, even though they're quite broad measurements, using that virtual staff gauge, they can track the real changes in flow at a river. On the graph here, we've got actual stream flow. The gray area shows actual stream flow measured with a hydrometric gauge at this particular site over time. The blue lines on the graph is a water level data similar to the data that's gathered using the Crowdwater app. And what you can see here is that water level data, again, even though it's quite broad data or quite rough data, I suppose, does track the changes in flow at that site quite well. So this data can be useful in hydrological models. This is a screenshot I've taken from one of the videos produced by the Crowdwater group as well. So it's available on YouTube if you want to take a look at it. So the graph here, the axes are in German, but I've just added some English to it to hopefully explain it a little bit more clearly. So on the very left, this navy blue line at the very top against a 1 is a hydrological model calibrated using hourly flow data. So, this is the model you get from using what I suppose could be considered more or less the best possible data that you could have, hourly flow data. What they did then was compared the hydrological models calibrated using this type of data with models calibrated using water level data, like the data you can get from the Crowdwater app. Here we have the results from using daily water level, so recordings taken every day using those water level classes from the virtual staff gauge. Give quite good results. So not as good, obviously, as if you had hourly flow data, but the results are quite good with daily water level class data. And if you even go to weekly water level class data, there's not much difference. So that's just about as good as using daily water level class data. On the other hand, if you go to monthly data, so if you only recorded a site once a month, that's not much different to calibrating your model with random data or not having any of this flow or water level data. So what they suggest is that you need at least weekly water level data and to get data that is suitable for hydrological models. So that's what we'll be aiming for with the Citizen Science Project. We'd be hoping that our scientists would be able to record weekly or more or less weekly at the sites that they choose. Okay, so as I'm talking about what we want our citizen scientists to do, just to look at that in a little bit more detail. So you would need to identify a river site that you're happy to monitor regularly and that you're able to monitor for changes in water level at that site using the virtual staff gauge from the Crowdwater app. There are different types of sites you could choose to measure at, and they fall within this hierarchy that I've just listed here. So firstly, if you're recording at a site that has a hydrometric gauge at that site or close to that site, so a gauge continuously measuring flow, that's probably the most useful type of site to target, because then we're able to compare the data that you gather on the Crowdwater app with the actual flow data measured using a hydrometric gauge. Now, there's a limited number of sites that have hydrometric gauges recording at them, so that probably won't be possible for most people. However, there are a lot more sites that have flow estimates from the EPA's HydroTool application. So if you could monitor at one of those sites or a site close to a site with one of these flow estimates, that would also be useful to us. Possibly you won't have any of those sites close by, or maybe you have a different site that you're interested in, a local site that you want to measure, and that's absolutely fine as well. If you can measure regularly at any site, we'd be happy to receive that data and we will be able to use it. But just looking at those first two types of sites with hydrometric gauges or sites with flow estimates. So how could you find out if your site falls within one of those categories? So you may or may not be familiar with the EPA's mapping system. So I've given the web address down there on the bottom, so gis.epa.ie, EPA maps. So using that site, we can find out if there is a hydrometric gauge measuring water flow at a site we might be interested in. I'll just link to the site or to the EPA's mapping system. Okay, so this is the EPA's mapping system. To look for hydrometric gauges, you can go into this water menu, choose monitoring, and you can select to put on the hydrometric gauge layer. Okay, so that should pull up all the hydrometric gauges around the country. You can then, I'm just going to zoom in and see in more detail where they are. So I'm just going to pick a site in Uachtarard and Galway. So we've got a hydrometric gauge here. You can click on it, click on those gauges, and it should give you information. So it pulls up the hydrometric gauge. If you open it up, there's a HydroNet link. If you click into that, it gives more information about the gauge. So it's a gauge that is managed by the OPW. It says it's measuring water level and flow, so that's useful. If you go down to the very bottom, you can click for more information on that particular station. So it's an OPW site. OPW site opens up this page here. You can click into this hydro data page for even more information. And if you just choose, in this case, year, so it says it's measuring flow. This shows you measurements that were taken over the preceding year. So this particular site is currently measuring flow. Not all sites that have hydrometric gauges have this continuous flow record. So by clicking in to the details at the site, you will be able to see if it is actually measuring flow. Okay, so that's how we use the EPA mapping system to find out whether our site has a hydrometric gauge close by. So if it does, great. If it doesn't, possibly it has an estimate of flow by the EPA using their HydroTool application. You can find that out by, so there's a layer menu on the very left-hand side of the mapping system. If you click on the WMS layer option, it should bring you up this list, this long list of different layers that you can select. The ones that you need to determine if there is a river flow estimate are the hydro catchments layer, the river flow estimates HydroTool layer, and the river water bodies layer. So you can type those into the search box and it should filter them out and you should be able to select them quite easily. Once you've done that, so I did it, here are the layers that I filtered out and they're on. And what you can see on the map here, these blue dots are the sites with estimates of river flow using this HydroTool application by the EPA. So there are a lot more sites with river flow estimates compared to sites with hydrometric gauges. Okay, so possibly your site will have a river flow estimate or will be close to a site with a river flow estimate, and that's great as well. So there are two most useful type of sites, I suppose. But as I said, if your site doesn't fall within one of those two categories, and you want to monitor it, that's absolutely fine. We'll happily receive any data. Okay, so once you've chosen your site, we need water level estimates from that site, and we need them as often as possible during the study period. So as I mentioned a few slides back, ideally we want records once a week. If we get records roughly once a week, that's better quality data than say records once a month. The period we're looking for records from runs from March to November 2023. Now, I know that's quite a long period. Possibly you can't commit to recording for such a long time. If you can't, that's absolutely fine. But we'd be delighted if you could commit to at least one season within that period. So our target seasons, spring, summer, and autumn. So spring is a 3-month season, March to May, summer, June to August, autumn, September to November. So, weekly records would have one of those periods would also be very useful. But obviously, if you could do the full year, that would be great. The Crowdwater app, as hopefully you've seen, is quite simple to use. Should only take a few minutes to record a water level at a site once you've got it all set up at the very beginning. So even though you may be recording March to November, it doesn't take long to take a recording each time. Okay, so hopefully you are interested in the project and you will be able to contribute some data for us. Just to mention, before I finish here, health and safety. So obviously, health and safety is very important. You'll be recording close to a river. There are opportunities for accidents to happen. So you are volunteering for this project, so you're taking on risks yourself, but your own health and safety is more important than a recording of water level from a river. So don't take any records if there is any danger or any risk of you having an accident or having an injury. Also, your choice of site should take this into account as well. So choose a site that there's easy access, it's easy for you to get to, and it's safe for you to record at that site. Useful to have a look at the Crowdwater terms and conditions. So if you go into the app on your phone and you click on that eye icon, you will get information such as this disclaimer here. So again, never record or contribute observations in unsafe conditions. Always take care of your safety first. And the project partners and apps platform can't be made responsible for any damage or accidents resulting from using the app or the service. And I'd say that the same for ATU. They won't be held responsible for any damage or accidents. So think of your own safety first. If you think it's unsafe, for example, maybe the site that you're recording at was fine on the first number of occasions, but there have been some changes at the site. There's been a rise or an extreme rise in water levels, which makes it not safe to record there anymore. Don't record. So gaps in the data, that's fine, much better than accident or injury. Okay, and there's a link to the terms of use of the app there, so you should read that before using the app as well. Okay, so after all that, if you are interested in volunteering for the project, the best way to do that is to provide your details on the contact form on our website. So you'll find that on the citizen science page of our website. Scroll down a little bit towards the end. You don't need to include a message. Once I get your name and your email address, I'll add you to our mailing list and I'll send you information about what we need our citizen scientists to do as that information becomes available. So once you submit your information, I'll assume you're volunteering unless you say otherwise, but you're free to take your name out again. So, by volunteering, you're not committing to anything. If you decide afterwards that you no longer want to volunteer or that you can't volunteer, that's absolutely fine. You can have your name taken off the mailing list. Okay, so this is the recording, so no opportunity for questions here, but there will be opportunities, there will be live events in the future where I will be able to answer any questions that you might have. We're planning to also run some events at river sites around the country, which anyone is free to attend if they wish to, and there'll be opportunities to see the app in action, how to record using the app, and to ask any questions there as well. But there's no requirement to go to those events. There's no requirement to attend the webinars. I will provide all information that any of our volunteers need once you've sent me your details. Okay, thank you very much.